Section 8.4, Modular Arithmetic. You may have heard of clock arithmetic. So for example, if it's 11 o'clock and we want to know 3 hours later, that would be 2 o'clock, because of course, once we hit 12, we basically go then back around to 1 o'clock. This is also called the integers mod 12. It's slightly modified for clock arithmetic because we don't have a 0 o'clock, but otherwise it's the same idea. Similarly, 8 hours after 10 o'clock is 6 o'clock. So again, we basically figure out how far we have to go to 12, and then how many more do we have to add. So let's look at some other modular arithmetic, and that little mod just tells you what is the number we're using there, how many digits we have. So for mod 3, we have 3 digits, 0, 1, and 2. And this is the notation you'll see for the others. So I would write that as 3 is congruent to 0 mod 3. And basically what you can think of that as meaning as 3 equals 3m plus 0, where m is some integer. So here I'm looking at that remainder. So similarly, 4 is congruent to 1, because I've got the remainder of 1. 5 is congruent to 2, because I have the remainder of 2. And as you can see, I've got a few more listed there for you as well. Similarly, if we did the integers mod 4, now I've got 4 digits. Again, when we do these, one of the digits is going to be 0. So since it's mod 4, we won't actually see 4 there. 4 is congruent to 0. We are then going to come up with what we call addition and multiplication tables. So we would add normally, and quite a few of the numbers are normal. But, for example, when I did 1 plus 2, I get 3. But as we saw earlier, I don't write 3 for mod 4. I would write that as 0. You can see that again here. And then, of course, 2 plus 2 is 4. But 4 is congruent to 1. So what I usually do is I would add, or in the next case, multiply normally, and then figure out how I would rewrite that number mod 3. And we'll have that little z-3 to indicate that we are doing the integers mod 3. And similarly, here's a multiplication table. So again, I am multiplying normally, and then finding that congruence if I need to. And that is about all that we are going to have to do with modular arithmetic.